When our grandparents built their communities, they used concrete pipe for storm drains and sewers. They knew that whatever the future held, the community's infrastructure would last. Today it's called sustainable development, or the practice of building infrastructure systems that meet the needs of the present generation without compromising the needs of future generations. And the foundation of a sustainable infrastructure rests on three pillars: economic growth and equity, conserving natural resources and the environment, and third, social responsibility. Today, we're going to take a brief look at each of those components and how they've become the driving force for designing and building new infrastructure systems. 30 years ago, it wasn't easy to see the link between reinforced concrete pipe and the global issue of sustainability. Today, however, the benefits of precast concrete pipe show it's a 21st century product with a performance record that spans millennia. Concrete pipe is durable, has the lowest life cycle costs, and a lower economic impact on future generations. What better product or material is there to specify within the context of sustainable development? Economic growth and equity, one of the legs of the sustainability triad, will become even more relevant in the next few years because of GASB 34. GASB 34 radically changes how more than 84,000 state and local governments must report their finances to the public. In order to include all existing major infrastructure assets such as roads, bridges, tunnels, drainage systems, and water and sewer systems under what's been called the modified approach, governments must perform condition assessments every 3 years. The National Cooperative Highway Research Program's Project 1904 states, how state DOTs respond to GASB 34 may have a significant impact on statewide costs of public borrowing, the long-term costs of infrastructure programs, and the proportion of agency funds devoted to construction versus preservation. The potential economic benefits of applying an asset management approach to public infrastructure clearly demonstrate the superiority of reinforced concrete pipe as the choice for sustainable drainage systems. Concrete pipe offers lower maintenance costs, and the projected service life of concrete pipe is substantially greater than that of HDPE, PVC, or corrugated metal pipe. Roughly speaking, a drainage system built today with RCP would last over 100 years. A flexible pipe may last about 50 years. Let's take an example of 1,000 feet of 24-inch pipe. Comparing all the costs involved, concrete pipe is the clear winner. Remember, pipe prices and backfill materials can vary from region to region, and these are examples only. But it's easy to see that concrete pipe is the hands-down winner when it comes to an economic assessment of each product. The concrete pipe industry has developed a software application called PipePack. It's an integrated analysis that easily compares flexible and rigid pipe systems, calculates earth loads and pipe classes for concrete pipe, and offers a variety of other design features. Using this software, a designer can create various economic models that compare different pipe materials over the life of the project. PipePack contributes to economic growth and equity by demonstrating and proving the best choice of product, so that a buried pipe installation lasts as long as it's supposed to. The second pillar of a sustainable infrastructure system balances the manufacturing, installation, and disposal aspects of the drainage system with its impact on the environment. Keep in mind that any type of pipe product consumes energy during its manufacturing process, but concrete pipe uses considerably fewer consumables in its manufacturing than does plastic or metal pipe. The manufacturing of precast concrete pipe involves a few basic materials that work together as a composite system: sand and gravel, steel reinforcement, and Portland cement. Local quarries, the primary source of sand and gravel for aggregate, can be reclaimed for recreational, residential, or commercial use. Although manufacturing Portland cement is an energy-intensive process, it only accounts for 10 to 15% of concrete. Fly ash and blast furnace slag, both industrial byproducts, are often incorporated into concrete. Even the steel reinforcement comes from recycled sources. To produce a flexible pipe like HDPE involves synthetic and organic chemicals, mostly from natural gas. PVC pipe also uses petrochemicals and chlorine extracted from rock salt. Concrete pipe manufacturers are involved in other environmentally sound practices too. For example, storm and process water is captured on site and treated. Oil and fuel products are strictly and safely contained. Much of the manufacturing takes place undercover, resulting in a cleaner and quieter community. During installation of a drainage system, concrete pipe has less impact on the environment. As we've already seen, a plastic pipe system takes more labor, time, and energy than concrete pipe to be installed properly. Often, trenches must be wider for HDPE or PVC installations, and they require a high-strength soil envelope for structural integrity of the conduit. Plastic pipe will require a special backfill, which must be transported to the job site and compacted with special care to prevent flexible pipe from deflecting or buckling. This raises the greater transportation impact of plastic pipe, that is, requiring additional fuel to bring in backfill and haul away native soil. On the other hand, native soil excavated for concrete pipe usually can be reused as backfill, because with concrete pipe the majority of the structure is manufactured into the pipe. Assembly is simple with concrete pipe too. The concrete pipe joint is tight, smooth, and resists infiltration and exfiltration. Once flexible pipe deflects, joints become more likely to leak. Pipe leakage may result in soil erosion and pavement damage. Like many construction materials, pipe has an end to its useful life and needs to be managed for disposal. When an agency specifies a pipe material, it's essential to consider what happens to the pipe after it's no longer capable of performing on the job. The material may be reused or recycled or perhaps delivered to a landfill or incinerator. Concrete pipe can be recycled and reused. It can be crushed to form road-based material. Concrete pipe has also been successfully used to create artificial reefs for fish. The final portion, and perhaps the heart of a sustainable infrastructure, social development, stems from the inescapable fact that we've become the first generation of people which has taken on challenges with roots in the distant past, challenges created by our nation over the past 100 years. Concrete pipe systems are one of the lifelines of our economy, carrying safe water to households and collecting stormwater and sanitary sewage for treatment and reuse. Buried concrete infrastructure is dependable and enduring, allowing communities and economies to grow. Concrete pipe producers are committed to developing a product that's part of a sustainable infrastructure and helping to achieve a balance between economic growth and equity and conservation of natural resources and the environment. They're well aware that performance, durability, and quality are major ingredients in the recipe for sustainability. The actions taken by the industry today are designed to be long-term solutions and to help lighten the tax burden of generations of Americans to come. Finally, don't forget, concrete pipe is a locally manufactured product. Over 300 concrete pipe plants in the U.S. provide jobs and contribute to the tax base in their communities. In short, along every step in the manufacturing process and use of concrete pipe, there's an opportunity to act in an environmentally sound manner while maintaining the needs of today and tomorrow's infrastructure. Because concrete is the most common building material in the world, its environmental attributes are readily accepted in the call for sustainable development and the use of long-lasting products. The concrete pipe industry throughout North America is ready to respond to the call by raising the expectations among clients for quality in every engineered precast concrete product delivered to a job site. By taking the lead to help specifiers and contractors choose the best product for any application, and by providing an asset that lasts and lasts. You can learn more about sustainable design from the Portland Cement Association by requesting their CD, Concrete, Sustainability and Life Cycle, or contact your local pipe producer.